Well, good afternoon, everyone. Thank you for inviting me. Madrid is, even in its under construction state, one of my favorite cities, so any excuse to get here. Jaundiced visionary. I used to be a consultant. Most of my working life was giving advice I didn't have to implement. And that all changed for me about 2 years ago when I joined TransUnion to solve a problem. And turned out it wasn't the problem that needed solving. And so I'm going to walk you through my experiences over the last 2 years and TransUnion's experiences over the last 4 or 5 with trying to live at what we call the edge of physics. So I'm going to tell you a little bit about TransUnion because I need to set the context of why we have these problems. And then talk about 4 problems that we've tried to take everything you've heard up until this point and some things you'll hear later and apply them to solve those problems and then describe what happened. So here we are. There's only 3 global players in my industry. So what that means in practice is we're not a market. Nobody builds products for our industry. Which, when you deal with vendors on a day-to-day basis, is one of those pieces of cognitive dissonance that it's really hard to teach people. Right? They all want to sell you what they have, not solutions to your problems. And all of their process has been tuned to make what they have sound attractive, whether you need it or not. So I was a consultant for 20 years, right? So I'm inoculated against this kind of selling. It's not really a problem for me, but my CEO, who I report to, is not a technologist. That's why he hired me. And he's a little bit subject to management by magazine. He likes to read about all the things that are easy that we don't yet do, and then ask me why. So what really interested me about TransUnion is that there isn't anything in what we do that isn't information. You look inside a bank, you find money wrapped in information. Well, you used to find money wrapped in information. Look inside an insurance company, you find risk wrapped in information. You look inside a manufacturing company, you find products wrapped in information. You look inside TransUnion, it's just information. So what I really do is I set direction for a factory that manufactures information products. Credit reports, about 1 million to 6 million a day, depending on the day. Scores for various kinds of things, 1 billion a day. Some really busy days we get to 1.5 billion. Risk management reports, portfolio analyses. And to do all of this, we've collected data for a long time, 30 plus years in TransUnion's case. Really good industry to be in, by the way. You have to start 10 years before you make your first sale, because it takes you that long to collect the data that the first sale is based on, and which gives long-term planning a whole new dimension in our industry. But we've got a lot of it. So we have about 30 terabytes in the core database. That's not a big database anymore. But to create a credit report out of it means we have to take 42 different sets of data and join them together, and we have to do that in less than 150 milliseconds because we have to deliver the answer in less than 500 milliseconds or our customers assume we're not there and go to one of our competitors. So my nightmare is the 501 millisecond credit report because I paid to produce it, but I won't get paid to deliver it. So we have a lot of data. If you live in the United States, this is really scary stuff, right? If you've ever borrowed money from anyone except your immediate family, we have a record of it. We have about 100 billion rows of data in our main databases. And you know, you should not be allowed to be in this kind of industry without a degree in physics, because entropy matters in really large data sets. So if I don't pay attention to every one of those 100 billion lines, they rot. Bits flip just by themselves all the time in really big data sets. So we update this stuff pretty regularly. We have about a couple of billion updates a month, and as it comes in from lots of places. It comes in lots of different formats. It all has to, and we get it for free. Great industry, right? Everybody gives us their data for free and we sell it back to them. Can't beat that, except because they're giving it to us for free, they don't really take any care of it. So it shows up dirty, inaccurate. And I know you'll find this hard to believe, but people lie about their creditworthiness all the time. Shocking, isn't it? And we have to try and figure that out, because the other nice thing about our industry is we get sued by someone for inaccuracies in data that we didn't create, but which we host, about 30 times a month. And every now and again, we make a big mistake, usually by trying to get into the wrong business, and the entire adult population of North America sues us in a class action suit. And you don't want to lose one of those. So one of the things that this results in for me is I have to move a lot of data. So every time somebody tells me that bandwidth is an abundant commodity, I realize they don't work for a provider of bandwidth. Right? Bandwidth is a scarce commodity unless you don't want much of it. You want a megabit a second, you want 10 megabits a second, nah, it's easy. I buy it in tens of gigabits a second, and I can't because carriers don't provision it in tens of gigabits a second, except to each other. So they don't have a tariff for it, so they make up really big numbers when you want to buy it. So moving data, and I have this problem, I don't have this problem over hundreds of kilometers or tens of kilometers. I have this problem over tens of meters. I move data from one in-processing environment to another all the time as fast as the speed of light allows, and it's not fast enough. So that's my working environment. This is what we have to do it. If you're not a technologist, you probably don't care. We don't actually count servers anymore. We count cores, because it's the cores that do the work these days. So I have around about 8,000 cores of Intel cores of processing capacity, and I'll probably never need more than that, because the amount of work I can get to go through a core stays about the same as the core technologies improve, not because they get faster, they don't, not because the pipeline structures get better, they don't, but because our ability to use them all together gets better all the time. Plus I have these 4 mainframes that just sit in the corner and hum to each other. We've been using this stuff in parallel for a long time. If you want to process 100 billion rows of data against a scoring algorithm, grid processing is a really good way to do that. We were early into that. We have a lot of experience with that. And in my internal cloud, with those 8,000 cores, they're all virtualized. They all run at 80 to 100% utilization all the time, which actually, by the way, is a power management nightmare, because all the technology around power management is designed to turn the cores off as much as possible, except we don't let them. There you go. And much of the capacity we have is batch processing. So not transactions. I'm a medium to small size transaction processor. I have a decent amount of e-commerce traffic, but I run a million batch jobs a month through the batch processing environments, and some of them last 6 weeks. The product guys, who are my internal customers, dream up new products that require big batch processing all the time. And in our industry, you cannot take a finished product to market until you've processed a whole bunch of customer data through it and given them a chance to play with the results. So I am forever trying to figure out how to put another 1,000 cores times 6 weeks of capacity onto the floor so that 2 product guys over 2 beers over the weekend can actually try their idea out. Because it doesn't matter if you can run 10 records through it. It doesn't prove anything until you can run 100 million. So here's why we decided about a year and a half ago to go and look for another way to do this. Right? Now, I should also tell you that we're private. We're the only one of the 3 bureaus that's private. So our economics are completely non-transparent to the marketplace. But my cost of capital is lower than the banks because of who owns me. So I don't really have a problem about spending capital, except that my CFO thinks that operating ratios are important. I've not yet managed to convince him of that. He's an idiot, but so we actually have to behave like we were a public company in terms of operating ratios, which has some challenges. And I'm worried about energy costs. I have all the electricity coming into my primary data center that my utility can provide without them building a new substation. Okay, it takes me roughly 3 megawatts to power and cool my primary data center. And I buy it from an intermediary, so I actually get it pretty cheap. It costs me about 7 cents a kilowatt hour to actually do this. But the trend is not encouraging. And my power efficiency ratio is 1.24, which is pretty damn good. But the trend is not encouraging. We're also finding that the more we do this stuff at scale, the fewer people we can find who understand how to run it. So we have a major talent problem. The talent we can hire, we can't keep, because in all the hot skill pools, everybody job hops, or they become independent contractors, and they're always shopping for their next deal. I got a lot of trouble by publicly saying that in the US a couple of months ago. And we looked at what you've heard this morning, and we've all heard for the last year or so, and we thought, you know, that sounds too good to pass up. Even if they're lying half the time, it's probably still a good idea. So let's go and try. So we did. So now you go and talk to the CEO and say, I want to do something radically different with the core infrastructure that runs your business. He's going to say, okay, tell me exactly what you're going to do. And he's going to say no to half of it. So we came up with 4 problems that we really wanted to take to the cloud and see if we could do it. So the first one was just to go after our non-production technology back office processes. We've been a Salesforce.com customer for quite a while at the time. We'd had a really good experience with it. All the things that Peter said about adaptability and ease of deployment and integrability are all true. There are some consequences to them being true that I'll get to in a minute. So we thought, could we do more of this? And the second problem I had was that every now and again, I suddenly need a lot more computing. I usually know when that's going to happen, but not always. So I really wanted to try and figure out if this really highly scalable stuff, you know, I've all seen the AWS charts 100 times now. And so when I saw the first one, I thought, okay, can I really spin up 1,000 cores in an hour, 10 minutes, 30 seconds? Now, what's the reality of all of that? And because we break everything we use at TransUnion as a sort of cultural habit, what happens at the edge cases when something goes wrong with the process is very important to us. My third problem is I got these petabytes of data that don't get accessed very often, but when they're needed, are needed really fast. And right now I have a room full of tape robotics that takes care of that with virtual tape systems in front of them. We have terrible cache ratios, so could we do something about that? And then lastly, I got lots of customers who would like to use me as a hosting repository for their data. I don't want to be in that business. But I don't want to say no to a customer. So is there some way where I can start to look for an intermediate hosting model that says, send it to us, we'll process it for you, and then we'll put it someplace that isn't us that you can go get it. So here's what happened. Software as a service is a winner. But the more your current state was customized to you, the more pain you're going to have in moving away from it. It's not impossible, and it's sometimes worth doing, but you have to look at where you are in the ownership life cycle of those assets before you can decide whether you should do it right now. And we look very interested. We're a PeopleSoft shop, right? We don't have SAP, we're a PeopleSoft shop. And it really isn't going to be worth our while on a yield for the resources against gain in operational cost. There will be a gain in operational cost, basis until probably the next natural refresh cycle for the current platform, which won't for us be until 2012. But it probably will be worthwhile doing it then, and we would start planning now to do it then. And then we're going to do a bunch of other stuff. I'm not going to read the slide to you. You can see that we think we can do this incrementally, opportunistically, and build over time, build proof points that make the business managers comfortable with moving in that direction. Frankly, I could care less about the IT managers. They'll either get with the program or find a new career. But I have to persuade the business managers, and in some instances, I have to persuade the regulator that this is okay to do. So offloading peak capacity. So we used EC2 and S3, and I have to tell you that the most impressive thing about this was how good Amazon's technical support was. Right? The lesson I learned out of this was not that you can provision thousands of cores on the fly to do a job that they have never seen before, because we proved you can't do that. Right? You can get somewhat close some of the time, but it's by no means a slam dunk. But what we did prove was every time we had a problem with that, there were people who knew what they were doing on the end of the phone or email or chat or whatever we chose to use, and they really knew how to solve the problems in their infrastructure. And that is, in the end, why some of this might be a good idea. Now, everything else was a nightmare. Okay, you send me a list of what the software environment I'm going to run in, and it isn't the same as the one I run in now. And it doesn't matter that we have these things called standards, which are a really good thing, and I know because we have so many of them. The fact that I'm running on Red Hat and they're running on someone else, bad news. The fact that I'm running on VMware and they're running on Zen, bad news. And it's not that there's anything intrinsically difficult to unpick here. It's that the application developers did not develop in the abstract. They developed against a programming model that they believed they understood. The code says they only partially understood it. But they built all kinds of implicit assumptions into the way the code works that do not translate from one set of quote-unquote standard environments to another standard environment. And the three words you learn to mutter under your breath are error and exception handling, which is different everywhere. But overall, this was a successful experiment. What we really learned was that for what we want to do, Amazon Stack is too immature today to be a reliable alternative to me writing a big check to HP, who I buy my servers from. Thank you for the servers. Or to IBM for some more mainframe capacity. So this is we're going to go in this direction. The existence proof is in that this works, but it's not a generalizable capability that I want to depend on yet. In an emergency, I would go there in a heartbeat. Absolutely would. This is the one where the laws of physics really get you. This is a great idea if you can move data fast. The trouble is, no one can move data fast at an economic cost. So I have a deal with Verizon. Verizon is my network services provider in the United States. So I have an MPLS network with Verizon. And they have these cute little devices called ROADMs, right, remote optical add-drop multiplexers, which let me, with about 5 minutes notice, burst the bandwidth on my gigabit connections up to OC192, right, which is 10 gigabits. And sometimes that's enough. Now, my problem is I don't need that for very long. I might need it for 30 minutes or an hour while I move a whole bunch of data to a customer or to a hosting site, but then I don't want it anymore, so I want to drop it back down to the gigabit connection that is just fine for the rest of the time. The carriers have plenty of capacity to do this. Believe me, there's enough fiber in the ground to cope with demand for the next couple of decades. What the carriers don't want to do is the optical engineering that lets you have that kind of flexibility. And and the United States, which is probably the most open market for that kind of service flexibility, even there, it's very hard to get anyone to sign up for that. Security in virtualized archives. So we're paranoid about security. When you sit on everybody's financial data, I mean, banks are paranoid, but they've only got their own customers. I got everybody's. So we build into our applications all kinds of tracing and instrumentation that tells us where things are and what's happening to them and who's changing them and what changed. And we discovered some kind of interesting things when we started pushing some of this stuff out. It doesn't always end up where we were told it was going to go. All that automation, that management layer that you don't have to care about, it's got its own mind about how to optimize stuff. And although no bits ever left the country, which was the basic SLA we had, some of them got pretty close to the borders and were clearly moving in an unpleasant direction. In-house, we physically destroy disks when we're done with them because it's cheaper than wiping them securely of the data they used to contain. I am reasonably sure Amazon's not doing that to the disks I put my data on. Nor do I think they have a policy to move in that direction.
Actually, we do for our obsessed 70 audit.
Yeah. So there's and they might destroy the disks when they're done with the disk, but they don't destroy them when I'm done with the disk, which is the fundamental difference here. And you know, those of us with security backgrounds go around retrieving data from 4 layers deep in the substrate on the platter all the time because we can. So that's a bit of a worry. Trying to get guaranteed performance out of the cloud today is employment for lawyers forever. I mean, I used to think outsourcing contracts were tough. Easy.
You've solved Peter's problem about what people are going to sell.
So everybody who used to be in IT is now going to get a law degree and become a service level agreement negotiator for a customer or for the cloud. And so those are the kinds of issues that we found. And guaranteed capacity is a problem too, but only because we're so big. It's for the little guys, I don't see that this is material in many cases, but for the edge case we represent, which is not unusual for large companies and is likely to be the mainstream in 5 years, we had some problems. And then the large data set hosting, this worked just fine too, but we're back to, we have significant immaturity in the overall environment for building a business model on this. So if I want to give my customers access to a hosted data set that I generate and put out there, and I want the hoster, who is actually recording when they come and use it, to bill them for it, and then pay me minus their agreed take, you'd think that would be easy. No, it isn't. When we talked to AWS about this, they say, what a good idea. I was hoping they would say, this is how to do it. Licensing models for the software we use. You want to see instant paranoia in software sales executives in major companies. Suggest that you want to run their software in the cloud. Right? And then try and find anything you actually do that doesn't have third-party software in it. Now, I actually do have some examples of things we do that don't have third-party software in it, so we were okay with that. But, you know, as soon as you want a database, well, MySQL is very competent technology, and we use it for metadata all the time, but it really doesn't perform with 100 billion row tables. So there are some issues to work out. The revenue model for software licensing in the cloud, I think, is a work in progress. In fact, it's a work in embryo. Hasn't even gotten to the born stage yet. But we'll have to get there before much of what we want to move moves. So what do we think we've learned? So the first thing we learned is I can't do this as cheaply as they can. Right? I'm not a small buyer of technology. I spend $40 million a year or so on hardware and software. But I can't get the unit economies that they can. In most places. The one place where we saw very close or I win is in high-performance storage, because they're not buying high-performance storage, they're buying commodity storage. And commodity storage, I have bad days sometimes at work, and when I have bad days, I get mean ideas. So we went and bought a whole, I don't know, 2,500, 3,000 disk drives, I don't know what, I lose count, in our production environment. So I went and bought 100 consumer terabyte drives, and I stuck them in an array, and I ran them on our duty cycle. Right? These are drives that come with 80,000 hour mean time between failure guarantees on the box. Right? No drive lasted more than 1,000 hours before catastrophic failure. So you buy that stuff in your Google and you got 2 million of them, and then they're popping off one at a time, and GFS is taking care of the data protection for you. Good luck to you. I can't do that. My guys aren't that smart. So we actually can buy large-scale, high-performance disk subsystems, and I have about almost 2 petabytes of them, cheaper, and run them cheaper than I can store that data for that purpose in the cloud today. Interesting to see where the trends are going, because drives are not getting faster, and although they're getting bigger, they're not getting more reliable. And if nothing changes, all of my budget will go to storage in 2015. Support was outstanding, as I said. Actually, support was outstanding from everybody we talked to. It's quite clear that this is a hot technology, that the providers are attracting really good people, that they've figured out that they need to provide great service, and they're doing it. Now, of course, they don't have all that many customers. So today, it's relatively easy to give great service. If they had tens of millions of customers, business customers, instead of hundreds of thousands, I question whether the service levels we're seeing today could be maintained. And my view is it's going to be a race between scale and deployed experience, so that people don't have the kinds of problems that we had. So you don't need people, you don't need good people to help them through it. You've already solved those kinds of issues. Trends are encouraging, jury's out about whether anyone will get there. Standards, we just have to get some standards around this stuff, and they have to be fundamentally important standards around how architectures work, the Google architecture, rather than the ones we have today. So I don't know that anyone's really figured out a business model. It's not easy to get permission to try this stuff, but you can. If you want to move computing around, it's a breeze. We actually moved one compute problem to 3 different clouds in a trivial exercise. You want to move data around, it's a nightmare. So I don't actually know what happens when the 100 terabytes of data I stick out on one cloud needs to go to another. Today, it would take us a year to move it. You will do that, but it would still take us months to move it all. You ever tried to rebuild an array with hot disks? It's horrible. If we're really going to make this work, my belief is that we have to rethink how we architect things. Because today we think very vertically integrated architectures, and even though I think we've solved the asynchronous design problem by and large, we have not solved the how not to care what's in the box problem when you're designing business solutions. The 2 big things that we really saw that we really liked were, this has the potential to solve my energy problem, because I can make it somebody else's energy problem. I just hope they're near hydropower and high-capacity fiber when they solve it. And it may help us get access to the talent we need to run the scale and complexity of our business that we cannot hire in the markets that we choose to locate our businesses in. So the thing that in the end, got me permission to do more of this was when I went to my CEO and said, if we don't play in this early, we'll be victims, not shapers. And that was a compelling argument to him because he could see the logic of helping to let the industry evolve the solution to the problems we have, rather than simply riding the tail of the economics, which was where we started from. So I think that was my most interesting learning. And I will tell you that the cloud graphic here was not constructed for this event. It was actually a standard TransUnion graphic, which I stumbled across in the marketing literature by running a search on Salesforce. But it seemed appropriate.
Thank
So
you,
thank
John.
you.